Okay. Right. Happy Wednesday, everyone. So today I have an extra special episode stream for you. Whatever. I have an extra special thing for you because I have my wonderful fiance coming on to discuss basically how to read a scientific paper. Um, so just before she pops on, she's just upstairs waiting. Uh, she is Dr. Amy Gillespie, and well, I'll let her give her qualifications, but she is more than qualified to be telling you about this kind of stuff. And essentially, what we're going to be doing is sort of running through an explanation of reading and interpreting scientific papers from the perspective of a kind of non-expert or even non-scientist. And we thought that this would be a good idea. Well, I think Amy originally suggested it, and I'd been thinking about some sort of vaguely similar things, particularly because um, no offense, people on Twitch, but some of you are not fantastic at reading scientific papers. Nothing wrong with that. It's entirely understandable. But as a couple of scientists, we figured it might be useful to kind of give a introductory explanation of some of the key points. So anyway, I will bring her on screen now, if I can. Oh, there we go. And I shall open up the sound. There we go. So, Amy, can you hear me all right?
Are you fine? Can you hear me fine?
Yep, can hear you all good. I believe the levels are coming through all right, and I can see you on the stream manager. So, yep, we're all good.
Slightly odd because I can see myself. Yeah, but out of sync. But
Yeah, that will be inevitably out of sync. I would recommend from recent experience, don't look at it too much while you're talking,
I've just
because
covered
it'll just yeah
it.
throw you off. Um, okay, so as I was just telling the audience, which I think you heard, we're going to be chatting about kind of understanding scientific evidence for the non-scientist, and I think it's probably worth emphasizing just off the top here that both of us have been training for quite a few years now in understanding this and in reading papers properly, and we still both make mistakes all the time. I think it's fair to say, especially outside of our field. And
Definitely.
yeah,
And yeah, like my master's was pretty much a year focused on how to analyze and critique and understand research papers, specifically in the field of psychiatric research. So that's kind of how long I've spent on a particular area. So outside of that field, it gets even more challenging.
yeah, I think that's a very important point, is the fact that we're we're not claiming here to teach you either in great depth or teach you how to read a paper in every single field and subfield. Not least because I think what I could tell you about systems ecology or quantum chromodynamics or I don't know, any one of the hundreds and hundreds of other subfields of science could probably fill a thimble. Well, maybe a little bit more about systems ecology, but still not a lot. Um, so it's important to understand here that we're both quite specialist within our fields. Well, I suppose a good way to explain it is Amy works in psychiatry, psychiatric research, and her doctorate was in psychiatric genetics. My doctorate is in neuroscience. Well, my specific doctorate is in functional neurosurgery, and my background is generally in neuroscience. So our fields are pretty related. There's quite a lot of overlap,
Yeah.
um, but still we need to help each other out a bit if we're reading. If Amy's reading a paper on fairly heavy like electrophysiology stuff, which she just hasn't studied much, if I'm reading a paper on well, just about anything related to genetics, which I've barely touched since undergrad, or a lot of clinical trials, she's much more experienced with. So we still need to kind of help each other out a bit, or at least it helps to help each other out a bit. So, if you're not an expert on reading every aspect of science after this, maybe hour and a bit of two people chatting, then don't worry. The idea here is more to give you just sort of a baseline so that you can maybe start to kind of calibrate your own understanding better and know a bit more when you shouldn't be confident versus when you should. That's kind of one of the things.
Yeah, some kind of tips to help with doing this, but also the general kind of message to be kind of cautious and when trying to interpret these things, because it's very hard even when you're within the field, let alone outside.
Yeah, absolutely. And I think this is one of our kind of top line points for people who aren't scientists reading scientific papers, and even people who are scientists reading scientific papers from slightly outside of their field. Uh, Exercise humility.
Yeah,
If we can communicate only one thing, it's don't be too confident when you read something that isn't very much in your area of expertise.
mm,
Um, because I think most of us in the sciences and a lot of people these days generally have had the experience of reading a paper or reading a few abstracts and kind of going, oh yeah, I think I understand this now. I've got a decent handle on it, and then speaking to someone who actually knows what they're talking about, and they kind of say, no, you've completely misread this. You've missed out this very fundamental aspect that everyone in the field knows about, but you just didn't have a clue about. Um, and the lesson there isn't, stop trying to read science or don't try to
yeah,
engage with this stuff. It's just realize that a lot of work goes into getting good enough and getting knowledgeable enough to put everything in context properly. And it is very easy to accidentally stumble into a field and make an ass out of yourself.
definitely. Shall we start diving in?
Yeah, sorry, I forgot you couldn't see me without delay. I was just blowing my nose. Um, so yeah, let's dive in a little bit. So should we start with the kind of these key messages? Just a few like top line points. So we've already covered kind of not practicing humility. Uh, Also, as a general, if you're going to take a couple of things away, uh, try not to read too much into abstracts. That's probably the biggest single pitfall, maybe other than the humility thing, that I see people making online, and it's for reasons that we'll get into a bit later. It's very easy to kind of read too much into something that often researchers don't put very much effort into writing, or not necessarily not much effort, but just the abstract is to some degree the least important part of the paper. Um, it's a summary and nothing else. Well, sometimes a lot else and a lot not good, but we'll get into that. And also, it's very important to remember that the quality and the type of the paper that you're reading is going to vary massively. So by this I mean both the quality in terms of some research is just not very good, some research is excellent, some research is very difficult to tell whether it's good or excellent, but also the the purpose of the paper, what the paper was setting out to do, varies massively depending on whether it's a like little opinion news piece that any grad student could have written in their lunch break kind of thing. Not that it's not useful, but going up to systematic reviews and meta-analyses and categories of evidence that we can be much more confident in.
Mm.
So again, that's something we'll cover in a bit later. But uh, so to start off, well, I guess Amy, how would you uh, go about searching for a paper on a new topic that you're not very familiar with?
So the kind of two steps I would generally take. The first thing I'd do is probably using Google Scholar as a starting point. So this is on your Google page, just another tab of the searches that you can do, and that's usually where I start off with my kind of key things that I'm searching for, because it combines research from across lots of different databases and lots of different types of places that hold research of various degrees. So it's a really good kind of starting point and it's quite easy to navigate. And then to actually get the paper, either you can see on the kind of right hand side that you can click right through to the PDF of the paper. If I can't immediately get it from the PDF, then I go to Sci-Hub, which is a wondrous place where basically all research papers have been uploaded to make them accessible.
Right. So for the purposes of my Twitch membership, Sci-Hub can be used for illegal activity. I would obviously recommend very strongly that you never ever breach copyright. Um, However, I will say that a lot of scientists don't particularly care if you are stealing their paper from a journal. And if you are to, say, for example, I don't know, try to find a paper here and find out that it's not openly available. I mean, this one is, fortunately, but you could copy this bit of information. This is called a digital object identifier. Copy from after the forward slash, after the little URL, this little bit here. It looks like nonsense, but it'll start with something like 10 dot a number and then forward slash and a string of letters and numbers. Now, if you were, make sure you've got the copy, all of the legal ability to access this. You know, don't piss off your librarian. But if you have legal justification for accessing it, then you can copy that little number into here and hit enter, and 9 times out of 10, you will get a complete original paper. Now, often we can get into this in a little bit. Often this is just a manuscript, so this one, this is an accepted article. So often it's not the fully published one, but it'll be basically everything you want.
Yeah.
And this is, I think, is she Ukrainian? I can't remember the Alexandra. This is the creator of Sci-Hub. She's a bit of a crazy anarchist, but she's also kind of awesome. Um, so yeah, obviously respect copyright at all times, citizen. But um, you can often find a lot of useful papers on there, and yeah, scientists don't really care if you're accessing their papers.
Most scientists, have put a lot of work into their science and want it to be out there.
Yeah,
So, I mean, another thing that we were going to say is that if you want to go about it another way, if you email authors, then authors will be very, very happy to send you their papers. If you tweet them or any other way of contacting them, they'll love for you to read it because they've put a lot of work into it.
yeah, uh,
Authors are not usually the barrier to trying to access papers.
yeah. Almost never. I think every time anyone's emailed me for one of my papers, I've been delighted and been happy to like get into a conversation with them about it because it's really nice having someone email you up and say, "I love your work," sort of thing, or "I'm interested in
It'll
your
probably
work."
make their day.
Yeah, yeah. So if you wonder who to email, most journals will have a little like letter symbol or a just a corresponding author, something like that. look for the person in the list of authors with who is either labeled corresponding author or with this letter, and you'll generally get, yeah, so you'll get a little link to their emails. Don't go spamming Dr. Turpos. I've just randomly clicked on their name. But if you did want to find a copy of this article and were unable to get the full PDF, then just email Dr. Turpos at the Department of Clinical Therapeutics. And while I cannot speak for Dr. Turpos, I would suspect they'll get back to you in the positive. Um, Usually, the reason why they wouldn't is just they're busy, and academics can be crap at replying to emails. Speaking from personal experience and personal behaviour.
Another thing worth knowing is that if you're trying to find like an academic's email in general, if for some reason it wasn't on there, or if you wanted to find an academic in general, I'm constantly doing this and just searching for their name, including the word university. Probably the right person will come up, and nearly all academics will have their contact details somewhere online on their university website.
Yeah, absolutely. Usually, academics make themselves reasonably easy to find. Actually, that brings me on to ResearchGate.
Mm.
Um, a lot of academics have, particularly in like the sciences, uh, have a ResearchGate page. It is the premier. I haven't got my login saved on this one, but it's a the premier academic social networking site. Um, don't ever sign up to academia.com. That thing sucks and
Oh,
that thing will spam you endlessly. Um, I don't have my ResearchGate login right now, but a ResearchGate page is pretty much like a Facebook page, um, and except it'll have projects where you can look at an academics that all the like projects they're working on, and they'll typically have their research kind of organized by project.
mm.
Um, and most people, or maybe not most people, but a lot of people will basically put all of their research up there, often including preprint manuscripts, which are generally legal for a an academic to share. It's like the manuscript before it's been sent off to the publishers and had all the editing and stuff done to it. So they're as good as the paper usually, just like a little bit less formatting. And it's generally legal for academics to put those up wherever they want. So ResearchGate is a great place for finding those, and also for getting in touch with the authors, because check that they're reasonably active on there, because obviously if they haven't touched the profile in a year, then they're probably not going to get back to you. But a lot of the time they will.
It's also a way of following academics, so you can follow them and get emails or notifications when they post new papers. So if there's an area that you're particularly interested in, that's another option to kind of
Yeah,
keep you on top of stuff.
yeah, absolutely. Um, we haven't explicitly mentioned PubMed. I think you did in passing, but I haven't brought it up.
Yeah, so PubMed, I guess Google Scholar is where I start if I'm just doing kind of a really general starting point. PubMed is the kind of formal database that I'd go to if I'm specifically looking in a particular area. And if I was doing kind of any formal review, this is where I'd go because it's a bit more limited to more established journals, but also a really, really huge database.
So, for example, if you wanted to look up this brain tracking and deep stimulation on autonomy paper, search PubMed for a relevant keyword. Of course, you have an advanced search here that you can use to, if you're familiar with like Boolean search terms or whatnot, you can, or searching all of the different query boxes, all the different possible boxes. Um, and yeah, it'll generally just give the abstract and maybe a couple of figures, um, the some similar articles, articles that it's been cited by, and
Mm.
citations within the articles. Um, I didn't know the Wellcome Trust funded that research. It's my research. Anyway, um, And yeah, it generally, if it does have a link to the full text, it'll be up the top right here. And if it's available for free, then it usually will have that link.
Mm.
If not, that'll take you through to a journal page. Let's see if I can find one for a non-free paper. I think this one isn't free. Yeah, so for a full text link for this brainjacking paper, we go through to Elsevier, um, which will link out, and you'll get this annoying little get access button. Unless you have university credentials, and sometimes if you do, don't bother clicking that. That'll be useless. Um,
That's the thing. Even with credentials, you often spend ages just trying to access a paper, which is why it defaults to other means usually.
usually our friend at Sci-Hub. So this is my own paper, and it's quicker for me to get access by searching for it on Sci-Hub. Which is that is that allowed under copyright law? Mm-mm, genuinely not sure. Um, we can. I mean, Sci-Hub has quite decent database of case law, so maybe we could go looking up the the legal standards there. But yeah, it's the whole system of academic publishing is a bit of a mess. So
Yeah.
I guess if you've got one takeaway here, it's that um, search for things on like ResearchGate, Google Scholar, PubMed,
Mm.
or other appropriate search engines. We're probably not as familiar with. PubMed is mostly for biomedical and like some sort of sociological, and it's kind of grown over the years, but um, you won't
Yeah, we
find a
should
lot
say
of.
that we're generally coming from the biomedical field, so some of what we're saying might be specific to those fields
Mm,
and it might differ for different areas, but some of the general ideas hopefully will apply to lots of different academic areas.
yeah, absolutely. Um, and yeah, so if you can find your paper through one of those kind of means, then between emailing the author, finding it on ResearchGate, and just going on Sci-Hub, then you'll probably be able to track down the original.
Yeah.
Um, oh, the other one which we didn't think about when we were plotting this out, but is if you're on Twitter or social networks, get in
Mm.
touch with academic colleagues. Uh, not
Yeah, I
that
constantly see people kind of posting saying, I can't find this article, does anyone have it? So yeah, or contacting the academics themselves on Twitter.
yeah, oh yeah, lots of academics on Twitter, and I mean, if you're Twitter friends with me and you ever ask me to find a paper, I'll probably dig it out for you. There's not an open service to serve the internet with free papers, but you know,
We like to
I
help.
yeah, and I don't think I've ever um, seen someone on Twitter or Facebook like someone I vaguely know call for finding an academic paper and not seen like half a dozen academics come in and be like, yeah, I've got journal access to that. I'll send you the PDF. Um, Again, strictly within the bounds of copyright law. Not sure. Ask a lawyer. Contact someone who knows about this stuff. But practically speaking, if you know a few academics, that's easy way to find it. Um, so once uh, you've kind of found your paper, um, which obviously can sometimes be linked from the media or whatever, uh, how do we uh, kind of search around that? How do we? Because it's often the case that if one is reading a new academic paper, particularly from a field that one doesn't really understand well, there's going to be things that you don't have the context for, and just information that you don't have access to. So, and this goes for people working in the field or working like tangential fields, unless it's really your hyper specialist field that you're the main one working in, you're not going to be able to understand every paper without extra context. So, where do we go for that kind of context and information around the paper?
I mean, the first things are, I'm sure, the things that anyone listening would think of as well. So, and we're partly just kind of normalizing that Googling definitions if they're words you come across that you don't know, just Googling them. Um, And Wikipedia. I use Wikipedia all the time as a kind of starting point or a place to find out the basics of something. And it covers so many areas of people, I'm sure, know. But like when I was looking into genes and genetic research, most genes that are kind of well characterized that will come up in research have a Wikipedia page that will at least give you some basics. So it's a really good starting point that I kind of trust. It's not the whole place that you want to go, obviously, but to start off with, Google and Wikipedia are great places.
Yeah, and just to kind of add to that, like your teachers may have told you don't cite Wikipedia in essays, and yeah, sure, you shouldn't be using it as a primary source in most cases, but it is one of the world's most fantastic projects ever created, arguably. It's
Yeah,
millions and millions of people contributing for free to a body of knowledge. And while it is certainly subject to biases and reporting errors and so forth, as a source to find a good set of links covering the kind of introduction to a field or some of the key papers, it is remarkably good, and particularly on more trafficked sort of scientific articles, it's pretty fucking reliable.
mm,
So, I like I say, don't cite it in your essays or certainly in your scientific papers unless it's a paper about Wikipedia. But uh, a lot of citations in papers I've written are just whichever citation is on Wikipedia for the fact I was looking at, because it often links the best source for that.
yeah.
So yeah, don't be afraid of Wikipedia. Don't think that it's not proper scholarship, whatever.
It's a lot better than a lot of other things on the internet. If you're
Yeah,
struggling with knowing where to trust and you're not sure, I would trust Wikipedia over a random blog by someone.
yeah, same here. Um, and though contrasting with random blogs, you do have things like the conversation.
Yeah, so we were kind of thinking of this as a place I don't know if everyone kind of knows about, but has a lot of articles written by scientists about their research. So, particularly if there's an area that's really tricky for you to get into reading the actual paper, it's very technical. It's worth looking and seeing if there are similar papers or the same paper kind of elaborated on in a more accessible way in the conversation. Scientists really do want to make an effort to make our work easier to kind of understand, easier to get the key points of. So looking for those articles that are written by the scientists themselves rather than non-scientist summary of them is a great place to start.
Yeah, so just as an example, one of the first things I clicked on, coronavirus and asthma, what we know so far. This is an article by, I think, Professor uh, Jamie Hartman Boyce from University of Oxford,
Oh, I
coincidentally.
know her.
Oh, there you go. Yeah, she's at the Centre for Evidence-Based Medicine. And yeah, well, I mean, is Dr. Boyce, Professor Boyce, a legitimate name within her
Yes,
field?
yes. I mean, I only know her very kind of briefly recently, but funny enough, I do know her, and she is the person that she says she is, and I trust her article.
There you go. Um, and this is a pretty standard thing for the conversation. I have written an article for it on animal research, I think, and that was a while back. But yeah, it's a great site if you want to just find out that
Mm,
solid explanation of the research. However, conversely, do be aware that lots of media sources are not so reliable. So I'll just show you this classic PhD comics strip of the science news cycle where we go in, the research, A is correlated with B, assuming C and D and E conditions, and then we go via the university press office who hypes it up a little bit, going into journalism where, that none of this is malicious. It's not that journalists are skeevy idiots trying to ruin the world or anything. A lot of journalists are excellent people, but they're working with constraints of
Mm.
the media attention available, and often ends up with very unreliable, misleading explanations once it's gone through a few cycles.
Yeah, everyone has their job to do, and often their job is to, sell the research, sell the papers, get the university more funding. So at kind of each step away from the actual research paper, you're probably going to get a little bit more hype, a little bit more simplification, a little bit more kind of selling the result as definitive. And that's kind of standard. Unfortunately, that's just the way it is, and you can understand why it is that way. But it's just worth knowing that and thinking that wherever you're reading it, you kind of want to take 2 or 3 steps back to get to the reality of the initial research paper.
Yeah, exactly. And well, when you were discussing this last night, you came up with a couple of good points. That first of all, if you are reading proper news articles, the quote from the scientist and link to the actual paper are often right down the bottom, if they're at all.
Yeah, so like the nuanced, cautious statements from the scientists are usually kind of, yeah, hidden away at the bottom. So if you want to get to them, probably scroll down.
Yeah, exactly. Um, so I guess before we move on to actually explaining sort of how to read a paper, um, it's worth well, you're more of an expert about this than I am. Could you kind of run us through some of the distinctions between different types of paper?
So the standard thing that probably a lot of people have heard of and is the kind of norm within academia is this peer review process. Now we could spend like an hour just discussing peer review and the advantages and limitations, but just as a very kind of brief summary of how it works. So for pretty much all kind of trusted established academic journals, as the author of the journal, you submit your manuscript to the paper and they find 2, 3, 4, 5 reviewers, so other academics in the field who hopefully have some expertise in that area, to read through the paper, give their critique, and make suggestions on whether it should be accepted straight away, whether it should have some revisions done to it, and then it can be re-reviewed, or whether it should be rejected. And this is intended as a way to kind of screen and make sure they're the reasonable quality of papers before they get published, to give them some credibility, and as, yeah, a kind of quality check. So that's the standard academic practice. And while it has its flaws, it's obviously, relying on individual people of varying expertise. Academics are asked to do it for free, so you get a lot of people who don't have time, don't necessarily have the right expertise or the right
Mm.
motivations. Generally, it does provide that quality assurance that other people who are qualified in the area, have given it a go ahead, have given it kind of a rigorous critique before it's going out there as an approved paper.
Yeah.
Um, on the kind of step before that, so one of the problems with peer review is that it takes a really long time to get papers out there. So the process of finding lots of reviewers, getting them all to give their reviews and send it back, maybe going through a couple of rounds of this, going through the kind of copy editing and the formatting and getting out there. Maybe you get rejected, then you have to submit it somewhere else. This causes a really big delay to getting research out there and getting the results out there.
Yeah, you're lucky if you go from submitting your paper to having it published within 6 months. That's like pretty
Yeah,
fast.
at the moment we're seeing a really like unprecedented
Mm.
turnaround of papers with COVID-19 because of the urgency. But yeah, usually it takes months. It can take years,
Yeah.
to get papers published. So people have kind of come up with these preprint servers as a way of getting research out there quicker. This isn't to necessarily replace peer review, and it's to be kind of taken with a pinch of salt. But the idea is that at least within academia, it's really good to be able to kind of get results out there to the rest of the field. So that other people can critique them. So it's kind of expanding on peer review rather than limiting it to the reviewers who are selected to do peer review. This opens up for anyone to respond and critique and have that chance to kind of make those adjustments before it gets formally published. But it also means that the results just get out there quicker, so that if someone else is planning on doing a new study, putting in a grant application for funding to do a new study, they can see what has worked, what hasn't worked, and use that. So we're kind of speeding up science. But it does mean that preprints on these preprint servers haven't had any review yet. So while I personally think they're a really positive thing for science, and then kind of opening up the critique and speeding up the process, you do need to take a massive pinch of salt when seeing a preprint, because at that time it hasn't really gone through any formal review at all.
Yeah, and as smart and capable as most scientists are, uh, sometimes we make mistakes. Um, sometimes really fucking big mistakes that get caught by peer review. And as imperfect as peer review is, and as Amy mentioned, it's very imperfect. It does provide at least a couple of eyes on who have the incentive, sort of, to read through the paper in depth. And something like medRxiv here, which is a fantastic site, it does a lot of very good work, but you've been seeing a lot of, here we go, these COVID-19 SARS-CoV-2 preprints from medRxiv and bioRxiv, which is basically a similar thing. And you've probably seen a bunch of media reports about these kind of articles. You know, new paper says, hydroxychloroquine great for COVID, or hydroxychloroquine terrible for COVID, or hydroxychloroquine does nothing for COVID, or whatever. And a lot of the time that'll be a preprint on medRxiv or a similar service, which doesn't mean it's bad research by any means, but it does mean that you should be extra, extra, extra cautious, and particularly if the paper is not being reported on by a specialist science reporter who might miss the nuance, then it's very easy to read too much into this very preliminary evidence, which 5 years ago, before medical preprint servers were widely available. They've been available in physics for quite a while, but uh, we would have just not had this stuff available for publication. It would have all been internal with grumpy old professors complaining about how bad the young postdocs statistical methodology is, or whatever. Um, but this is much more warts and all kind of science.
I mean, one benefit is that you get to see the critique that's gone on. So if you are going to look at preprints, it's definitely worth looking at the comments um, underneath them and the kind of sites that add critique to preprints, because that's part of the point that it's putting out there in a fresher, earlier way so that it can be critiqued.
Yeah, so if we look at this random paper, for example, um, we can see tweets referring to the article, um, comments. Nobody's posted a comment actually on medRxiv yet, but you get to see this peer review kind of taking place in real time. Peer review is calling it is maybe a bit generous, but this kind of discussion
Informal,
process.
it is
Yeah,
peers who are reviewing it.
yeah, exactly. It's peer review, but not capital P, capital R. And yeah, again, it's going back to the kind of overarching theme of practicing humility outside your field. With this paper, say sex differences in immune response to SARS-CoV-2 that underlie disease outcomes. Now, I've got a undergrad degree in physiology. I had some lectures on the immune system, and I can probably read through this paper and give you a good idea of what it's saying. But when it comes down to the specific methodology, if we open up the full paper and go to the methods section, let's say, once it decides to open up, and this is going rather slow, isn't it? Maybe the servers are overwhelmed. Um, and yeah, we go down to the study design here. I mean, I know most of these words. No, I can give you a reasonable explanation of what all this stuff is. But when it comes to, say, the analysis here, and here you go, the specific analysis of cytokines and chemokines, this is all getting a bit above me. Um, so I can't make a very strong criticism of this paper, and as such, I should probably be uh, fairly humble when it comes to trying to interpret its results. And that's not to say that it's useless for me to read through it, but it just means that maybe I shouldn't be making strong conclusions based on it until it's been through a bit more checking.
And to kind of give an example of the things that might happen with peer review that help ensure a higher quality or more credibility when you read it. So, I mean, a lot of papers that I have peer reviewed, often the suggestions I've made haven't been ones that fundamentally undermine the research. The research itself might have been really good, and be worthy of publication, but I've made suggestions that I think are really important before it gets published, such as certain quality control checks of the biological samples, or kind of cautioning about how they've interpreted part of their findings, whether they're being kind of too definitive or too positive, or ignoring contradictory messages that might confuse things. So a preprint might be based on solid science coming from a good lab, but that extra check of peer review can really make a big difference in how nuanced and careful the interpretations are, and how many kind of quality checks they've gone through.
Yeah, absolutely. Um, so I'd like to focus a little bit now on uh, the types of journal and types of article that we're talking about. So briefly first, I guess it's obviously, as anyone who's vaguely familiar with science will know, there are some highly prestigious journals, some less prestigious journals. Um, Now, the interpreting what that means in on a given study is probably beyond the scope of this. I guess in short, you sometimes get really crap research being published in low-ranking journals. Sometimes you get really good research published there, just because it's a super niche journal, but just happened to be the one that really fit, or because the authors got rejected from a high-end journal and just went, oh screw it, we'll put it in any old journal, because they didn't want to mess around with time. Not that I'm bitter about one certain paper, but uh, beyond that, there's also a lot of really shit research published in very high ranking journals.
Yeah.
And it's, without putting anyone too much on blast, there is a tendency for certain high ranking journals to like to publish uh, maybe more exciting research, things that has
Yeah.
bigger implications and is more of a amazing shock to the field, which is understandable. They are the journal of big science, and they want to make a huge impact. But perhaps unsurprisingly, sometimes a paper making the strongest, most exciting claims turns out to be a little bit bullshit. That's not necessarily like a big fraud or anything. Actual fraud in science is pretty fucking rare, but there's a lot of instances of scientists falling prey to their own hype, or getting overly excited about some results, or making a mistake and it making its way through peer review. These things do happen. Um, so just because you're reading something in science or nature doesn't mean it's great research. But conversely, just because you're reading something in the Journal of West African animal behavioral ecology that has an impact factor of 1.2 or something, um, could still be a really good study. And to be honest, often like some of the low-ranking, I've seen some low-ranking, oh, thank you, uh, journal articles that are really excellent. So, however, oh,
However,
yeah,
yeah, the one thing you definitely want to be watching out for are what are generally kind of termed these predatory open access journals. Um, so, open access as a general thing, for those of you who know about it, I hope you think of it as a positive. The general idea of open access journals is making, publications open access so that anyone can read them without having to pay for a subscription to the journal. However, there are kind of ethical open access journals, and there are these ones called predatory ones, and you can get online lists of predatory open access journals. And the way they work is that basically they email out lots of people, inviting you to write an article, and as long as you pay up the kind of processing fee for the journal, they'll publish you. And so it's both a bad thing for authors who can kind of fall into these traps, of publishing in poor quality journals and paying a lot of money
yeah.
for something that isn't worth it, but also for anyone reading these journals. You could trust it thinking it's a great journal when actually not so much. So if you're kind of unsure if it's a journal that you haven't come across before, it can be worth just Googling the name of the journal, checking that it doesn't crop up on any of these lists. Also looking at the kind of about sections of journals. The more you kind of read papers, the more you'll get a sense of what's typical on a kind of well-respected journal website, and they'll usually outline, their process for peer review and various things like that. And some ones, when you look at the journal, most people will probably be able to spot straight away that it looks quite different. So I know there was one journal that I came across a while ago that had like a forum designed for its peer review, which isn't necessarily a bad thing to have the kind of discussion openly, but the forum had maybe like 5 different people who contributed, and it seemed to be that the same people were on the authorship list for every single journal there. And when you dug into it and searched around for the name of this journal, basically it was an academic and his friends all reviewing the same papers and putting them up there, but there was no actual peer review, no like critical peer review of it whatsoever. And there were actually papers, really significant papers that are used to like justify scientific racism and
Oh,
stuff like that.
that's really slimy. Oh wait, did oh I think I know this
You
group.
probably
Yeah,
heard of
yeah.
it. Yeah.
Oh, those fuckos.
Um,
Yeah.
yeah.
Oh, actually,
So
this.
particularly anything kind of controversial or something that you're not sure about, it's definitely worth going back to the journal page and just having a little look around.
For anyone involved in Twitch drama, I think JF posts some of these things. Some don't worry, long like a big racist asshole with crazy views on population genetics and
Yeah.
whatnot. But more generally, um, JF, whatever his name is, yeah, doesn't matter. Uh, Point is that yeah, there's a whole bunch of these journals. It can be really difficult to spot them. If you're in doubt, like Google the journal name and predatory, or look it up on
Yeah.
Wikipedia. Um, but like I've had supervisors emailing me going, "Hey, we've just gotten this great invitation to publish something in this interesting looking new journal. Do you have anything in the pipeline that we could stick in there?" And I've had to email back being like, "This isn't a real journal." Um, and it's not that my supervisors are being idiots or anything. It's just that some of them are really quite difficult to distinguish. Um, So again, we won't spend hours and hours getting into, how to separate them all out, or the very challenging, thorny issues in academic publishing, but definitely be aware that, and this isn't to say that all open access journals by any means are bad. There are a
No,
lot of
I'm a huge fan of
excellent.
open access journals, and it is normal for an open access journal for the authors to pay some money, because basically, instead of the system, an open access journal, rather than making the readers pay to view it, you're making the authors pay to make it accessible. So just because you see a journal, there's kind of a fee publishing article, doesn't mean instantly that it's predatory or
Yeah.
bad open access. That is the norm. Um, it's a bit more complex. So researching to kind of hear about, yes, someone in chat has just posted a kind of directory of open access
Oh,
journals, so
excellent. Thanks, Ben.
ones that you can kind of trust. And we're planning to have, I think, discussion or stream at some point specifically about these issues of open science and open access. So if you're
Yeah.
interested, you can
So
tune into them at the time.
stay in, stay in, stay tuned, stay following, etc. But yeah. So if you see open access, don't think it's bad, but do maybe just be a little bit suspicious and a little bit careful that it's not something that's predatory, particularly if you live on the internet. If you're like us and spend all your time on the internet, then you probably will get a decent feel for it. In some ways, the kind of general understanding of what is a spammy, shitty website will hold you in good stead. But yeah, just stay skeptical, my friends. Um, so yeah, I guess next it's worth talking a bit about. um, so when you think of a journal article, of a scientific paper, a lot of people, I think, don't really get that there's a quite a big distinction between the different types of paper that can be published in a scientific journal. Um,
Mm.
Now, the gold standard of these is sort of in-depth, rigorous, systematic reviews and meta-analyses. And you have some professional experience in the area. Wouldn't you enlighten us as to what these are?
Yes, so I've done a couple of systematic reviews. They're an absolute pain to do, but very worthwhile, and I think where the field, well, where science in general should go. So the basic idea of them is kind of in the name. It's reviewing the literature on a particular area, so reviewing all the papers that have been published on a particular area or to answer a specific question, but doing it systematically. So historically, reviews have been done in a way that's called like a narrative review. So someone kind of picking the papers that they think are relevant and kind of bringing them together and drawing up the themes. Same as the way that people write essays,
Mm.
coursework. You're kind of picking out the things that you think are relevant to highlight. Now you can do that very well, and you can have the best intentions of doing that, but it's very easy with that to go down certain pathways, to be biased,
Mm.
to miss papers in journals that you don't really read or that don't support the ideas that you think are true. So the idea of a systematic review is that it prevents those biases happening. That before you start with your review, you have to make a kind of plan of exactly what papers you are going to find. And then you have to break it down, all the steps you're going to follow. Ideally, you put that plan online and have it reviewed. Um, the common one that I've used is Prospero. Um, and then you go through that plan. And so, for example, a kind of common thing that systematic review is used for is to establish whether a particular treatment is effective, whether a drug helps in some condition or a therapy helps in some condition. And so before you start, you might predetermine, or you would predetermine, which databases you're going to look at, and which search terms you're going to use, how you're going to decide whether a paper is relevant or not. That might be I'm going to include all papers that include people with depression and that have been diagnosed in this particular way, that have this particular drug given to them in this particular dose. Very, very specific. And then you run your search terms and you have to go through every result that comes up and decide whether it's relevant or not. So usually you'd first just look at the titles and maybe the abstracts, the kind of summaries of the papers, and say, this definitely isn't relevant, I'll exclude. And this one maybe is relevant, I'm going to have to read the paper itself. And this can involve looking through thousands of titles and abstracts. Ideally, if you have a really well-defined kind of question, then it will be maybe more hundreds. But you're still ultimately going to be looking through each and deciding whether it is relevant to the question that you've asked. Ideally, you have another person who does this separately as well, and then you compare your results. And you also might predetermine exactly what information you're going to draw out from those papers, which results you think are going to be interesting, which bits of the methods you think are relevant for understanding them. And then you're going to report all of those results very clearly and in exactly the same way, so that it's not biased towards the results that you like or that support your arguments. So that's kind of a general overview. So it's trying to bring a lot of objectivity to these reviews and making sure that they comprehensively look at everything, making sure you look in places that you wouldn't usually look, making sure that gaps in the papers, you've emailed the authors to ask them so that you have that information. And ideally, if once you've done a systematic review, meta-analysis is a way of analysing the results you get from all those different papers in a way that kind of provides a summary result. So you might have lots of different papers that say whether a particular drug helped on certain symptoms, and then you want to combine them all to kind of get an overall estimate of the symptom reduction that that drug produces, and kind of weight it by so that the larger studies or the better quality studies are influencing that result slightly more. A good systematic review will also be kind of assessing the studies for their quality, because you could gather up lots and lots of papers in your review, but if they're all really badly done papers, that doesn't give you better answers. So it's kind of aggregating and getting a better quantity, but it should also be assessing the quality as well in determining what your ultimate conclusion is to try and answer these questions.
And
But any systematic review, ideally, if it's done relatively well, is going to be obviously a benefit over looking at an individual study, because you're looking at lots more evidence.
yeah, and I would just emphasize there that sometimes a systematic review, you might read it and it says, you know, just not enough information. We didn't have enough information to like make a firm conclusion, and that's always okay. That doesn't mean it's a bad systematic review. Sometimes it can be a really good like call for action for doing further work. Um, but sometimes papers will do both in one. So you do get some like systematic review and meta-analyses. Sometimes they'll just do one or the other. Um, and like if a systematic review is saying there's not enough evidence, that doesn't mean that a cure definitely doesn't work or that it definitely does work or so forth. One of the not so much issues with them, but one of the design goals of them is that they hold evidence to a very high standard, and that they are doing a very kind of challenging interrogation of the evidence. So you do sometimes get things that work, but don't appear to on systematic review just because you know it's the evidence isn't strong enough yet, or vice
Yeah,
versa.
and it's also I think you do get differences of opinion in people who run systematic reviews. So I know topics where two groups have looked at the same kind of issue of a systematic review, but because they think that different methods are the best way to go about it, they've kind of come to different conclusions. So systematic reviews themselves aren't necessarily definitive, but they give you a much better overview of what's going on than an individual study.
Yeah,
And you can read this systematic review and kind of get a sense of whether you think that it's been done in a sensible way. And it's at least should be very transparent about what it's done. That's the key thing. That even if you end up disagreeing with it, you should be able to see all the steps that it's taken, how it's got to its conclusions.
Yeah. And if you're specifically looking at medical questions, the Cochrane collaboration here at Oxford, well, it's worldwide, but kind of based here at Oxford, is absolutely fantastic. They produce, well,
Incredibly high quality systematic reviews, yeah.
I'm just going to go grab some Coke, but you please continue enlightening the audience.
Um, so yeah, I mean, when I've done systematic reviews, they've been kind of doing them alongside my other research. In evenings, pouring through lists of titles and abstracts and trying to go through them and convincing someone else to go through them as well. So we have two people looking at them. For Cochrane reviews, you have people employed specifically to look at this and full teams who invest a lot of time because they're so important for determining, they're often used to determine health policy. So they really invest a lot of time and energy in doing these really, really thoroughly, with really tightly focused, well constructed plans, and lots of people checking them to make sure that there isn't bias. Um, and so yeah, so this isn't to dismiss the benefit of individual studies at all or other types of articles. They're really, really important as well. And it's really good to have kind of an understanding of them and to refer to the original study if you really want to look at something in detail.
I mean,
But
for
particularly,
just going to say
particularly
for what.
becoming something.
Oh, sorry,
Oh,
no. I was just going to say for one, you couldn't have systematic reviews and meta-analyses without the original studies.
yes, yeah, exactly. um, but particularly becoming something new, uh, that's usually the first place that I would look. If I'm trying to find out something, I will look for the systematic reviews that come up in the search terms. I mean, when I had a friend messaging me recently asking about kind of medical advice in an area that I didn't really know much about, when I wanted to kind of help them and I was looking through, I was looking for the systematic reviews to see what they had come up with in that area. Oh, and someone in chat is just mentioning how for social sciences, there's a similar website and kind of collaboration, the Campbell collaboration. So Cochrane is generally about kind of like medical interventions or treatments, but clearly there are kind of other initiatives in other areas.
I wasn't familiar with that. That sounds really interesting.
No, I've never heard of it.
Well, there you go. That's an excellent demonstrator of how like restricted scientists are sometimes in their views of their field, because we're both moderately familiar with social science stuff, like as kind of uh, like generally interested people, but yeah, neither of us can claim to be an expert in the field, and it shows sometimes. Um, and yeah, I'm sure there are, for each of these, as we mentioned at the start, for each of these uh, types of study or organizations, it's very likely that there are a bunch of them outside of our field that we're not even vaguely familiar with. But yeah, let me just open the Campbell collaboration because that sounds really good.
There's someone
Interesting.
asking in chat about the systematic review is required only where it's not possible to actually get a clear result from a single trial or experiment. I would say that I mean, it's hard for any individual trial to give a definitive result or answer.
At least in biosciences or social
Biosciences,
sciences
yeah.
or whatnot. Obviously in physics, like provided you haven't got massive measurement errors, you can kind of just publish a paper and then, at least to some degree, and then that's the
Yes.
new understanding. Um, but yeah, that's not so much the case in the biosciences and yeah.
Yeah, anything involving humans is messy. and depends on your participants, and there's lots of noise. So you might have single trials that have such strong evidence that it goes straight to informing policy or treatment or clinical practice or stuff like that. But generally, it's always better to have the results of at least a few different trials evaluated collectively.
Yeah, particularly as one is talking about anything beyond like the most straightforward trial intervention.
Mm.
Um, yeah, we'll usually listen to multiple systematic reviews, not least because it's very rare to go from um, no evidence about a given intervention to a really huge, well-designed trial. It's much more common to we'll do some animal studies, it'll look promising, so we'll test out a few volunteers and then, test it out in some different models and kind of use that research to inform a larger trial on people with the condition and then kind of gradually build out. So by the time you actually reach a single trial that could give you a definitive answer, you've probably already got enough material for a systematic review or meta-analysis of the data, not least because you'll have different teams asking slightly different questions about the same topic. Um, so, yeah, it's pretty rare to get to the stage where you're introducing any notable new treatment that you can't do a systematic review for.
It's worth noting that in some fields it's becoming more common to have kind of big collaborations working on something, so that you can do a meta-analysis kind of in one go. So particularly in genetics, it's becoming increasingly common to have international collaborations of lots of different teams collecting data, running very similar studies, but doing it independently in different groups, and then doing a meta-analysis that combines the results of these multiple different groups so that it gives kind of that higher quality of evidence quicker, and making sure that everyone's using kind of the same methods and the same approach. So you will sometimes see meta-analyses that are kind of all done in one, reported in one paper.
Yeah, this is true. You get some of those big multi-center studies where, it's got thousands and thousands of participants worldwide, but these things are extremely expensive to implement
Yeah.
and a nightmare to organize. Uh, Obviously, that's not to say they shouldn't be done or anything by any means. They're hugely valuable, but yeah. Um, so I guess we should probably move along a little bit,
Yeah,
otherwise
we've
we'll
given
have
a lot
the
of background context, but
yeah.
yeah,
But I think
important to know.
I think that's all important stuff that should should provide people a good basis. So we get on to reading a paper. So now that you've found it and you've understood what type of paper it is. Oh, sorry, just one thing. We talked about the best quality reviews there. On the other end, you should be aware that some articles that are in journals, even like legitimate high impact journals, basically aren't worth much beyond someone shouting into the void. There are, opinion and news articles in most of these journals that, though often interesting, aren't anything more than, some grad student's essay on the topic. Um,
Sometimes they can be useful. So often you'll have like a commentary on a paper that's published in the journal, and looking at the two together can
mm,
be really interesting because then you kind of get two perspectives and a critical perspective on that study. But yes, an individual opinion piece should be taken with a very, very large pinch of salt,
yeah,
especially if you're
and
outside the field and don't know how to kind of critique it or the context.
similarly, even I think we might touch on this a bit later, but even a single paper, I see this one of the most common mistakes I see online in the kind of scientific discourse, like popular scientific discourse, is finding a study that seems to demonstrate whatever you're arguing in favour of, and
Mm.
then citing that as if it's kind of the final word. We have found a scientific study, that's fine. There's a scientific study that backs up what we're saying. Whereas, in actual fact, there are probably going to be a bunch of studies addressing the same topic, and even then, it's easy to make mistakes and to make errors with statistics, or just have a completely legitimate false positive with no mistakes made. It's just you happen to pick a unusual sample or something like that.
Yeah.
So individual studies that are from one lab and looking at kind of one issue, do be very skeptical. Um, it's not at all to say that scientists are bad or doing a bad job or whatever. It's just science is really fucking hard, and sometimes we get things wrong. So all these systematic reviews and meta-analyses, the point is to aggregate a bunch of smaller studies and make them more reliable as a whole. So please don't get hung up on like individual one-off papers addressing something that you think is relevant, unless you are you know very knowledgeable about the field. And even then, I see a lot of people who are knowledgeable about fields making dumb conclusions based on, sometimes myself included.
Yeah,
Uh,
it's very easy to do.
yeah, so certainly before we go on to actually reading the paper, none of this is you're doing a bad job, so you're a bad person. We do bad jobs sometimes. Everyone does, and it's just this shit's hard.
Yeah, and it's good to just check in with yourself and think, am I immediately kind of jumping on this paper because it supports what I already believed previously, because it backs up my point in the argument I'm having with an annoying person on the internet? Or have I taken a step back and actually, critiqued it and looked at the quality of it? And that is why I'm, so interested in it.
Yeah. Okay, so reading a paper. Now that we've given an hour and a bit of caveats and pitfalls, um, I guess first, kind of what does each section of a paper mean?
So, um, do we want to do abstract first, or do we want to do?
Yeah, should we? Should we? Yeah, let's do abstract first because that's uh actually no, let's do abstract last because that's usually the last bit of the paper written.
Yeah. Um, so again, it depends somewhat on the field. We'll be talking mainly about our fields, but core basic sections of most papers, usually in this order, will be your introduction, your methods, your results, and your discussion. And with your introduction, kind of starting from a very general background on the topic and then narrowing down more and more into at the end of the introduction, you're focused in on the specific reason why you're doing the study that you're doing, and the kind of aims and predictions that you have for your study.
One thing I find there is the more familiar with a field you are, the more of the introduction you can skip.
Yeah.
So with papers on most areas of neuromodulation, I will skip the first couple of paragraphs that are talking all about the history of this procedure and they basically cite the same few things every time.
Yep.
Pro tip: if you want some citations, write a decent paper on like the history of a field, and you'll get cited in every introduction. Um, so but that section is very useful if you're not at all familiar with the field. Um, Sometimes it can be useful just to like read some introductions of papers because they can give you a decent background in what's been published recently, what the kind of paper in the field was, the like founding paper, because most fields have one or two like canonical papers, um, and also can be useful for trying to gauge what the authors think the field is and think the important things in the field is, because that can be a matter of opinion. Um, well, it's always a matter of opinion. It can be a matter of highly divergent opinion, and yeah. So sometimes just reading a few different papers, introductions, and leaving the rest of the paper can be useful if you just want that kind of
Yeah,
broad
that kind of
background.
context.
Um, but conversely, sometimes the introduction is one of the least um, least carefully crafted bits of the paper, because it's sometimes seen as particularly the first bit before you're actually explaining what your experiment is. It's just a bit of a pro forma explanation of the field. Sometimes people don't really put much effort in. Occasionally,
And if you're short on time or wanting to read lots quickly to get a general sense of things, which I'd say is usually better than kind of investing tons of time in one, depending on what your purpose is. A lot of the introduction is one of the things that I personally would skip, or at least the start of it. I would go to the end of it to
yeah,
understand what the aim of the study is and what the kind of specifics are. But I wouldn't invest tons of time in reading the 6-page preamble if it's a long
yeah.
introduction.
Usually, yeah, certainly if you're familiar with the field, last paragraph to the introduction is kind of
Yeah,
a necessary. The rest of it.
yeah.
Methods.
So methods are pretty much what you would expect from the name. So this is telling you the method that the authors took. And ideally, a really well written method will tell you everything that you need to know to be able to produce the same study again.
No such paper exists. Like,
Maybe we have tons of supplementary materials as well, maybe.
I would actually argue the no, we're getting way off the topic there. At some point, we'll have to do a discussion of like implicit and institutional knowledge in science because there's
Yeah.
some, but yeah, theoretically at least.
People put more or less effort into this aspect of things. But critically, is that it should tell you the fundamental kind of decisions and approaches that were taken, um, the types of participants that were included, the types of tests that were run, where it was done, when it was done.
How many
Um,
participants, how the planned analysis was going to be done, like
yeah,
yeah,
all the key things that are going to help determine how you interpret this paper, how much you trust the results, how well it was done. Um, really, really, probably most important section, but also one of the ones that is hardest to get into if you're outside the field.
yeah. Method section. Um, Honestly, if I'm reading something outside the field, I'll often kind of skip over it or just like skim it because sometimes it's just so dense that you don't really have a chance at understanding it unless you are, practically in the same research group as the authors. Um, Often not so much, but it's one of those things that you can kind of take from it as much as your expertise will allow. It is probably the most important section for actually critiquing the paper,
Mm.
at least when it comes to obviously the methodology, um, but can be the most impenetrable section.
As it's worth knowing, some fields it's normal to have the methods at the end of the paper.
Mm.
So if you're looking and are confused about where they are, sometimes scroll down and you'll find the methods hidden at the bottom.
Yeah, and as Amy mentioned, supplementary material. So some papers, well, as we'll mention in a moment, a lot of papers have very limited space to write in. A lot of the time, particularly if you're doing a very technical experiment, you will give a kind of overview of the methods and, here's how many participants we used and here's the general paradigm we used and so on and so forth. But the actual details of their setup will all be contained in supplementary material, which is a bunch of poorly formatted spreadsheets and whatnot that they'll link to on the journal page, web page, or whatnot. Um, Supplementary material can be, like I say, can be a bit of a nightmare because nobody really enforces like good formatting and so forth in it, and
But
yeah,
often the really important details are there if you're
yeah,
going
that's
for the in-depth, proper critique of them.
yeah, absolutely. Um, so yeah, methods, without kind of giving you an explanation of each different field and how they approach it, I don't think we can really go into much more detail beyond the fact that, once again, exercise humility. If you go through a methods page and don't understand it, then it's fine to admit it. Just don't try overly critiquing the paper if you don't know what half the words are. Um, Not least
You
because
will get familiar with some of the key things, and one key thing in the methods section will be kind of the design of the study.
mm,
So that's things like whether you're doing an experiment, whether you're observing people, whether it was done online or not, whether it was, you know, a large cohort, so a large group of people, 1,000 people. So and kind of keywords from there you might be able to kind of pick out and recognize Google to understand, and they'll give you a sense of the general idea, even if you can't
mm.
understand all the technical bits of it, the general approach that was taken, and you might gradually kind of learn the kind of benefits and drawbacks of the general different approaches.
That is a really good point, particularly at the start of the methods section. It'll usually have we used a longitudinal, uh, mixed methods design or whatever. Um, and they'll have those kind of keywords there that if you just Google them, you can at least find out how the overall study was being set up. Um,
Wikipedia has pretty good like explanations of a lot of these common study designs, so if you're not sure what it means, Wikipedia, as I said earlier, is a good place for that kind of
yeah,
thing.
things like cross-sectional, retrospective, these are terms that tell you the kind of time frame and the design of the study, within subjects, between subjects, etc. Just Google them. We can't go through each and every one, not least because they vary hugely by field. We're only familiar with the kind of biomedical ones. But however, conversely, if you do come up with a critique and it seems like super basic, or it's just something like, um, uh, it doesn't seem like they've explained this enough, there's a pretty good chance that the authors have been constrained by space, and that what you're thinking of is just kind of a standard assumption in the field. A lot of the time, methods will not include all of the things you need to do because um, you know pithing a Balpsy mouse is just a standard thing that nobody in the field needs an explanation of how to do every single time they read a paper. And for some reason, journal articles, despite almost all being online these days, often have a very restrictive word count. So you get your 3,000 words to write your article, and if you want to spend a bit more time on the explanation of your results, well, you've got to cut out that bit of the procedure that basically everyone knows how to do anyway, or everyone in the field. Um, so yeah, sometimes the gods of the word count make mockery of us all, and um, it leads to a less comprehensible paper for those who aren't particularly au fait.
Mm.
Um, so discussion, I think,
Well,
is
results.
next. Oh, sorry.
If
Yeah,
results, there's less to talk about. The results are telling you the results of what they did, and ideally, this usually is. Um, I'd say ideally the results are slightly boring to read because they're presented just like the pure facts.
some
um,
tables and
the tables, figures.
diagrams. Yeah,
Um, Often something that if you're in the area you really want to dig into, if outside of the area is going to be a little bit harder to interpret. But hopefully, it's kind of systematically going through the tests that they've run, the results of them, and how they kind of relate to the questions that were being asked. And
yeah,
then after that, the discussion, which is kind of going on from just the kind of facts of what was found in that individual study and summarizing them, interpreting them, giving context, critiquing in kind of like a reversal of the introduction. So where the introduction usually starts off very broad and narrows down, in a discussion, usually you'll start off with the kind of summary of these specific results that you found. So if you really just want to know what core thing did this study find, the first kind of paragraph of the discussion should tell
yeah.
you in a couple of sentences basically what the study found.
We noticed that there was a significant difference between Group A and Group B on this metric, and
Yeah.
this means.
then
then
it will
yeah,
expand out into, breaking down the results, giving some context of how they fit into the broader research, whether it is what the authors expected, their explanations for maybe unusual results that have come up, and also some space for, critiques, important aspects that should be kind of borne in mind while interpreting the study. And then usually it will end with, again, a kind of short conclusion that's kind of taking the main findings from the study and maybe the kind of implications of that.
as a general, very rough rule, um, I've noticed a lot of really bad papers um, just kind of don't have any criticism of their own results, any like discussion of limitations. It's a very rough heuristic, but if you go to the um, discussion section and find that they don't say anything about like limitations or drawbacks to their approach or anything like that, that's a pretty big red flag.
Yeah, often there's not enough space to, give the really full critique and limitations that we'd like to include in the paper.
Yeah,
But if there's none whatsoever, that's definitely a red
yeah.
flag.
At least like a nod to, you know, we used this animal model as we are aware this animal model provides some limitations in this area. Maybe a link to another paper discussing those in more depth. But we thought that it was appropriate for these reasons. At least want a little bit of, a nod to appropriate humility.
Yeah.
And yeah, so that kind of gives you, and going to the last paragraph of the discussion, that's usually when you get or the last couple of paragraphs, usually when you get to the kind of how does this fit in with the broader
Mm.
paradigm? How might it be used to, you know, develop more cures or push forward research in this direction? That's the kind of big picture, um, you know, sum it all up kind of
Mm.
space. And then, of course, there's the customary cry of more research needed, which
Yeah.
some papers, some journals ban these days just because
But more research is always needed.
it is,
Pretty much.
it's true. Um, and then we circle back to the abstract.
Yeah, so then the abstract is usually written, well, has to be kind of written after you've done all of these bits, and is a very short summary of the paper, usually with a very tight word count. Um, and so it's kind of a mini version of each of these sections. So you usually have, intro, methods, results, discussion, or conclusion, but kind of a couple of sentences for each of these. And so it's really useful for getting, a general sense of what the paper is going to say, and whether it's kind of relevant for something that you want to read or not. But it is massively condensed and by necessity doesn't have a lot of the detail that you need to understand it, and often is going to be sound slightly more definitive than the results or conclusions in the actual paper are. Um, so I would always kind of be slightly skeptical of what the abstract claims. It's probably a kind of step below how definitive the abstract is.
Yeah, I think that's a good rule of thumb. And also, it's worth remembering that the abstract is often rewritten if, as Amy mentioned earlier, quite often you'll go through with one journal, get quite far, and then it'll get rejected. So you go to another journal. The abstract is something that almost always needs to be rewritten because it's an easy way of like focusing your article a bit more to what this journal wants rather than what the first journal wanted. Um, the length allowed for an abstract varies. I've seen from like um, I think the shortest I've ever seen was like 150 words or something, and
Yeah.
then like sometimes up to like 600 words. So the space available varies massively. What they actually want varies massively, and honestly, a lot of scientists, I say a lot, a fair chunk of scientists, don't care that much about the abstract because they know that everyone in their field is going to take a look at the paper and go, okay, well, I need to read through all of this and break it down. Um,
We naively hope that people will be really interested in our papers and read them in great detail and give them lots of feedback.
because clearly everyone coming from that Daily Mail article is definitely going to want to read through all of my methods and see what statistical tests I used. um, and scientists are naive idiots, just like the rest of us sometimes. And say the rest of us, we are, particularly I'm a naive idiot all the time. Um, so don't assume that it's a fully accurate or even necessarily fair explanation of what's in the paper. Some people will just write misleading abstracts. Sometimes it's someone different from the person who actually authored the bulk of the paper writing it. So there's just so many reasons to be skeptical of papers just based on the abstract, and
Yeah, the
they'll
idea of the abstract is really to tell you whether it's a relevant paper for the question you're trying to answer when you're looking through the research. It's not a good place to go to for the definitive kind of answers and conclusion on what you want to take away from that paper.
yeah,
It's more to determine whether you read that paper in the first place.
yeah, and a lot of scientists will write with that in mind and try to make it a little bit not exactly clickbaity, but the sort of thing that they're quite sure their colleagues will want to read. Um, so yeah, that's not to say abstracts are useless by any means. I will often, if I'm just looking to like get the broad consensus of a field, I might look up the top few recently published papers and just kind of get a skim their abstract, see what they're saying,
Yeah.
and see whether this perspective is obviously nonsense or worth considering, something
Mm-hmm.
like that. And as Amy was saying earlier, they're extremely useful for systematic reviews. Um, and for just getting an idea of what's inside the paper, but please don't cite abstracts as the actual like top line of research. I guess if there's one takeaway, it's from this, it's that you should try to look a bit deeper than the abstract. If necessary, um, sorry, never ever break copyright in order to do so. But if you were to, I understand they've got that good shit on Sci-Hub. But yeah, it just dig down deeper into the paper if you can, and
Even if it's just scanning the like key paragraphs, the end of the intro, the a
start of
little
the
look at the
discussion.
method,
Yeah,
and the first bit of the discussion, that is going to give you more nuance and probably slightly more cautious wording than the abstract itself.
yeah, that's a really good takeaway. I think rather than the abstract, if you only read, if you're only going very quickly over the paper, last sentence of or last paragraph of intro, first one of discussion, and then maybe a bit more if you need it. But if you only read two paragraphs, those two are probably better than the two or three paragraphs of the abstract.
Yeah.
Um, okay, right. We've got a bit more here on like keeping track of notes and that kind of stuff. But I figure that's maybe a little bit technical for we're kind of doing the
Yeah.
broad level, and we are at an hour and a half already. Um, so I guess we can move a bit to sum this all up. What kind of, or to put this in context a bit, I guess, what kind of recommendations would you have for either non-scientists or non-specialists who are trying to generally improve their ability to read papers and to get a broad understanding?
Um. So in various different fields, like we kind of said that kind of getting a sense of the key kind of study designs and the benefits or drawbacks of them can be a really kind of key useful thing that's going to help you. evaluate papers, so getting a bit of kind of understanding of the key terms in the fields that you're interested in. Um, Statistics is another thing that we don't have time to go into, and it's obviously a huge area um, where you can get various levels of expertise, but just spending a little bit of time on the basics of statistics, understanding what a p-value is, understanding kind of the standard approach to evaluating the differences between two groups of patients, say if you're looking kind of the biomedical field. A bit of kind of intro to stats is going to be invaluable in kind of improving your general understanding and helping you critique papers.
Yeah, absolutely. I think if there's one kind of key tool for better understanding science is just a basic knowledge of statistics. I say this as someone who's not amazing at statistics by any means. Amy's really the stats whiz in this house, um, but nonetheless, even just a little bit of knowledge does help you get an idea for when someone presents a number. Are they presenting a number that makes sense? Are they presenting a number that oh, thanks, Geek with Glasses. Um,
No.
and just trying to oh shit, Geek with Glasses rated with a party of 29. God damn, I only just noticed this. Oh, thank you very much indeed. That's lovely. Um, yeah, so you're catching us at the towards the tail end of an explanation of how you read scientific papers and why it's important to get a little bit of knowledge about uh, how to do so before you kind of start delving deep into the literature. Um,
This is another
and
thing I just wanted to flag up, that we were talking earlier about kind of the importance of reviews and how useful reviews are as a kind of starting point. Reviews, another, as well as reviews kind of giving you a summary of the results in an area, reviews will often highlight the kind of key methodological issues, the kind of key challenges or questions, the key types of studies being done. So that's another way of kind of getting a grip on the terminology and the things that you want to look for when you're then delving into individual studies.
yeah, exactly. And you don't need to be an expert in this stuff to get useful information out of studies. Um, I guess since we've got a big influx, I'll kind of viewers just go over again the key top line messages. So we've seen a lot of people on Twitch, on YouTube, in blogs everywhere who are enthusiastic about learning more about science, but who will often make readings of papers that give a misleading account of what the science actually says. So, if you're not a scientist, please do continue reading papers. Please do continue getting interested because the public interest in science is absolutely critical for getting good science done and for an educated populist electorate. So don't stop by any means, but um, one, practice humility. So try to know what you don't know, and when you're looking at something outside of your field, just be cautious about drawing too firm a conclusion. Don't read too much into the abstracts because, as we've just been discussing, there are lots of reasons why scientists might write a shit abstract or why the abstract might just not be giving you the full story.
Apart
Um,
from being that they have to be very short, so even if you have the
yeah,
best intentions, they're not going to have a lot of detail that you need.
um, the quality and type of paper, of journal article, varies a lot. So if you want to go back and watch over what we've just been talking about, um, the difference between like a random opinion piece in even a prestigious journal like Nature and a well-designed systematic review or meta-analysis is huge. Um, Similarly, the difference between some random piece published in an open access journal, sorry, a predatory open access journal that anyone could just trivially publish in, versus a very well considered and peer reviewed paper by leaders in the field is pretty substantial. And often it's not easy to tell which is which. And finally, which I think is maybe a good kind of overall sum up point, is that both of us have spent years and years doing this. Many people have spent decades and decades doing this and still make all kinds of mistakes. So, do not. Uh, oh, F. Uh, is the stream going wonky? Ah, shit.
Mine went now it's come back.
Oh, it's going.
Unstable.
Yes, it's saying unstable. Hmm. Yeah, I seem to be. Let me see. That's not anything on my end, is it? Uh, Streamlabs. No, Streamlabs is running within. Uh, right. Ah, bugger. How are we doing, folks? Can we
I think
hear
it
or see
seems
me?
to be working in now.
Oh, it's going. Well, this is bloody night. Sorry, new people. Um, right. I am honestly not sure what's going on here. So, someone in chat says the lamest says the point about difference between opinion and nature versus good systematic review is more or less where it cut off for me. Um, cool. So yeah, we're just sort of saying that the the quality of the paper can vary both in terms of how well it's done, which is sometimes indicated by the kind of how high end a journal it's published in, but uh, by no means is a guarantee. But also the type of article it is. So, an opinion article is very different from a systematic review, even if they're both published in the same journal. And then after that, I was just sort of mentioning that the that many people spend a very long time learning how to do this. Both of us have spent years learning how to read papers and critique them and write them, and yet we still make plenty of mistakes. Um, and there are professors who've spent literally decades, literally, their entire working careers trying to do this, who still have trouble opening PDF. Um, so it's very difficult. Don't feel embarrassed or let down if you open up a paper and find that you don't understand half of it or even all of it. Um, Try to read introductory stuff, try to read more broad explanations, and Google is your friend when it comes to finding out more stuff. Um,
Yes. I think another key message is just reiterating that idea of not getting stuck on an individual paper. Um, so really what you're wanting to look for is kind of consensus patterns across lots of different papers and people saying similar things, whether that's summarized in a review or you looking at lots of different papers a little bit to get a sense of those patterns.
yeah, absolutely. And since we've just got a big load joining us, I would like to say that the Postnormal channel does not support any kind of violation of copyright, but if you were to, say, find a random paper that you can't get access to and copy this little bit um, of the DOI here, digital object identifier, copy this bit and paste it into sci-hub.tw, and 95% of the time you will get the PDF regardless of whether you have journal access. Now, you should only ever do this if you have legitimate access to the journal, um, but you
And
know,
making you aware that it is a thing that exists.
it is a thing that some scurrilous individuals might use to gain illegitimate access to journals. So, just be aware that some naughty scientists out there might be doing that. Um, yeah. Cool. Okay. Is there anything else you think is important to bring up while we've got people here?
I'm just seeing comment from chat about being very clear the opinions of scientists are opinions and not science itself. So yeah, kind of reiterating that idea that looking back at the actual results and actual findings of a study is a much more objective way of looking at the science rather than those opinion pieces or the interpretation. And same within papers themselves, looking at the actual more factual bits, the results and methods, um, and taking sometimes a bit of the interpretation and stuff in their discussion with a pinch of salt. And the more that you know about a field, the more that you can do that.
Yeah, and I think actually that raises kind of an interesting point about scientific consensus. So when someone claims that there exists scientific consensus, first of all, it's worth trying to find out whether this claim is true, because there are people who will claim consensus on matters that there isn't really a strong bias either way or whatnot. Um, but assuming such consensus does exist, it's worth having a little think about what that actually means. So, as a rule, scientific consensus is a good way of going about judging the truth value of things. Um, in general, most of the time, science seems to be the scientific consensus seems to be more right than not. Excuse me. However, it's also worth remembering that it's by no means 100% guaranteed to be right. There was reasonable scientific consensus about the area outside of Earth's atmosphere being composed of phlogiston a 150 or so years ago. Obviously not true, um, but it was less untrue than the planets all being crystal spheres in perfect circles. And it's if you don't have a strong reason to critique the consensus, it's generally a good idea to kind of assume it's true for the purposes of everyday life. Um, but remembering not 100%. However, being able to find one person who disagrees with the consensus isn't an argument against such consensus existing. Um, I think this is generally important thing to remember is that with the availability of the internet to reach out to converse with anybody, you can pretty much find a member of any given group who will espouse any given opinion. You can find evolutionary biologists or geologists who believe that young Earth creationism is literally true. There's not a lot of them, not a lot of them at all, but one or two, you can find them. Um, and the absence of unanimity on a point doesn't mean that scientific consensus doesn't exist. Um,
Yeah, and just because a scientist somewhere says X, just because we're scientists, just because we have a PhD, doesn't necessarily make us right. And that becomes even more true the more out of our own field we're stepping.
Absolutely. There is, of course, the aging physicist syndrome, where I was actually having a conversation about this for new people. Go back and watch my conversation with David Dunning, uh, Professor David Dunning of the Dunning-Kruger effect, and we had a very interesting chat about just this issue of people kind of stumbling outside their field and sometimes generating really useful insights. There are the 20th century is littered with examples of emeritus physicists who steps outside their field and produce some really interesting insight. But it's also replete with examples of them stumbling into completely unrelated areas and just making massive idiots of themselves because they thought that all of the decades of accumulated knowledge in their field would apply nice and smoothly to other fields where it often really doesn't. Um, but yeah, but conversely, within a field, disagreement is often a lot subtler than it might seem.
Yeah, some level of disagreement is really normal and really healthy. You kind of want a research field to have people critiquing each other. That's how science improves and how science gets better. Um, but often the kind of disagreements within a field can be exaggerated by the media, or when you're reading it, you can kind of pick up on it and think that there's these really drastic disagreements, when often it is, as I said, subtler. So, for example, the area that I work in, looking at antidepressants, very controversial area with lots of kind of differences of opinions, both in the kind of general public and within the field. But the disagreement within that is often smaller, I would say, than is portrayed. So most people will agree that antidepressants have some effectiveness, that they're not a cure-all, they don't help everyone, they don't solve all problems, we should be looking at other things, but that they have some benefit. And the kind of disagreement comes mostly over the degree of improvement. Is it a kind of 15% reduction in symptoms, or is it 25% reduction in symptoms, or is it 40% on average? And which of those should we be saying is good, what's meaningful? Um, and so, yeah, when you're kind of seeing disagreement in a scientific field, often it is over these kinds of matters of degree more than kind of very big fundamental things. So, of course, sometimes it is over big fundamental things as well.
Yeah, and I think in sort of SSRIs for depression, that's something that has become, or at least was a few years ago, not really quite so much anymore, but was for a while quite a big topic of controversy, um, where, as you say, the debate was portrayed in the media as being some scientists think that serotonin is the only system involved in depression. Some scientists think that there's nothing to do with serotonin in depression, that SSRIs don't work at all. Whereas in actual fact, you've got some scientists thinking that serotonin is the dominant system in depression, and SSRIs maybe account for a, like 45% improvement. The other group thinks that, there are other systems that are more important, though serotonin is an important system, and that it accounts for, 25% or something.
Yeah, I mean, within the department here, you in Oxford in the psychiatry department, you have people working on very different aspects, very different kind of opinions about this, but all of them would agree that SSRIs have some benefit to some degree, but are not the whole picture and not the cure-all, and it's kind of a matter of degrees in between.
And this is, if you ever notice a scientist who hasn't had a lot of media training, speaking in the media, when they get asked a question and they go, well, or hmm, or any of those kind of responses, that's generally indicative of them trying to sum up a very controversial and complex field uh, in a way that is accurate but also doesn't piss off their colleagues and doesn't give undue representation to their research, or so it's very difficult to communicate these consensuses sometimes, and especially when combined with the fact that scientists are human, and sometimes we do want to convince you that our view is the consensus one. Um,
Mm.
so yeah,
I guess this goes back to the general point of, if you're coming to a field new, I would say read broadly, get the sense from lots of different papers at first, and as you become more familiar with an area, then dig into the specifics. But getting that broad sense of where the disagreements are, where the consensus is really useful and really important.
yeah, absolutely. Um, Right, I think we'll probably move towards wrapping up there because we have been going nearly 2 hours now.
Mm-hmm.
Um, but I'd first of all like to say big thanks to my subscriber base. there's only two of you so far, but it's very much appreciated. And of course, all my followers. Um, Also, excellent, massive thank you to Geek with Glasses TV, who's a bit of a legend in his own right and does some really cool politics stuff over on his channel. Go give him a watch, give him a follow. Uh, and yeah, I hope you have enjoyed our little explanation. If you are new and liked this, we go into more detail over the last like couple of hours, but um, do give me a follow or check me out on YouTube or whatever. Just follow my shit. It's lovely. Um, perhaps most importantly of all, though, thank you, my wonderful fiance, Dr. Amy Gillespie, for being here and giving us, helping to make this into more of an interesting conversation and less of just a Laurie rambles at the screen.
My pleasure. And if there are any areas that you want to dig into more in future streams, I'm happy to come back.
Excellent. And also, I think the links in the about thing on Twitch. I don't know. I do have a Twitter if you want to ask me questions midway between streams. Then I'm generally happy to answer them on stream. So yeah, I guess with that, we will be off. But I hope everyone's enjoyed, and I'll try to clip this into a bit of a YouTube video because I think this is a useful topic for the kind of online discourse. I see a lot of people referring to papers without necessarily understanding what they're doing, and I understand a lot of scientists. Their kind of response is, well, people shouldn't be reading this stuff. It's not for the general public, which I don't think is a good way to be communicating science and be engaging with it. Um, and yeah, so without rehashing anything, I think it's fair to say that we're both big supporters of public understanding of science, and yeah, we want more of you out there to know about the work we do and the work that scientists around the world do, because it's really important for good policy and good future outcomes. Yeah, so thank you very much for watching. On Friday, I will be doing an AMA and my usual cocktail making while playing New Vegas. Well, I'll make the cocktail first, and then I'll play New Vegas, because making cocktails while playing New Vegas is challenging. Uh, I am not actually certain what cocktail I'm gonna do yet. Um, if anybody has suggestions or requests, Twitter, Facebook group, whatever. Um, and yeah, anything else? Oh, next week I'll tell you about the cool stuff I have next week because I should get into the habit of advertising myself more than now that I'm doing online stuff. Um, so yes, next week we have on Monday. Yes, allow you to send notifications. That's not helpful. Sorry. Uh, on Monday, I am chatting with Dan Pryor, who is a fellow at the Adam Smith Institute, and we are going to be discussing the war on drugs and why it sucks and how to end it, which is both quite a pertinent topic at the moment and one that both Dan and I have been very passionate about for quite some time. So there probably won't be a huge amount of strong disagreement. I don't know, actually, there might be a fair bit of disagreement about tactical stuff. We agree in principle, but how to get there, I think we might have some disagreements on. Either way, promises to be an interesting discussion. So that's 8 p.m. UK time, 3 p.m. US East Coast, next Monday, the 15th of June. Um, yeah, so without further ado, happy Wednesday, everyone. Thank you very much for tuning in, and please do like, comment, follow, subscribe. Generally, reinforce those learning algorithms so that machines will learn to love me. Ta-ta! GDWP. Thank you. GG indeed.